Welcome to Chem 1A, Fall 2014 at Shasta College. This is Mark Blazer, your instructor, and we're going to start off with Chapter 1, Matter and Measurement. The first question for you is, what is chemistry, and why are you taking it? Well, we'll explore this in a little bit more detail during lecture, but you may have already taken a chemistry class and encountered atoms and molecules and elements and compounds and things like that. In other words, you've dealt with matter, the stuff that makes up our universe. And then you're probably aware that how matter changes or how it reacts with other matter is where the interesting part of chemistry lies. In other words, the interactions of matter. So in brief, we can define chemistry as the study of matter and its interactions. Now, there are some things that you should probably already know, at least somewhat, and on the off chance you haven't spent all summer studying chemistry, we'll do some review, do some relearning, and maybe you might even run across some stuff that's new to you during the start of the semester. Let's start with this. Matter consists of about 100 different, and you'll probably say, elements that are pure substances that cannot be broken down, at least not chemically, into anything that's simpler. Each of these unique elements can be represented by a unique symbol. And some familiar examples include things like copper, symbolized by Cu, gold, symbolized by Au. This one might be a little tougher to guess, but it's the element sulfur, symbolized by S. And then, possibly tougher yet, this is the element bromine, symbolized by Br. And you'll notice that the chemical symbols are 1 or 2 letter symbols. The first letter's always capitalized, the second one's always lowercase, and sometimes the first letter or first 2 letters of the element's name in English. Sometimes a slight difference from that, and sometimes quite different, like for example gold. Au doesn't seem anything like gold, but it comes from the, or for many elements it comes from the Latin or Greek name for the element. Now these elements, these pure substances, are organized in something you've probably seen before, and this is of course the familiar periodic table. Now the periodic table consists of some horizontal rows, which we call periods, and here's the first row or first period. There's the second, and the third, and the fourth, and the fifth, and then the sixth row or sixth period actually does a little bit of a detour into the bottom chunk of the periodic table before it completes its journey across the row. And then the seventh row does the same thing, but note it follows all the elements in numerical order. The periodic table also has vertical columns, which are known as groups, or we sometimes say families. Elements within a given group have similar properties. So here's the first group or family, the second, the third, the fourth, and if you keep going across the periodic table, by the time you hit the end, you will have done 18 vertical columns or 18 groups, although some of the ones in the middle are clumped together in more than one column as a group. Now, there are some groups that have names that are fairly common, and the first column, which is group 1 or group 1A, these elements are known as the alkali metals. Now you'll see an alkali metal demonstrated in class, some of its properties, but as a general rule they're shiny and soft. They have low melting points. They react with oxygen, and they react quite rapidly with water, and when they do they make hydrogen gas, and they turn the solution basic or alkaline, hence the name alkali metals. Now the second column, which is group 2 or group 2A, is known as the alkaline earth metals. And the alkaline earth metals are also lustrous silvery metals, also react with oxygen, but they are less reactive to water than the alkali metals. Now if we jump all the way almost to the far right of the periodic table, the next to last column, which is group 17 or 7a, these elements are known as the halogens or halogens. And the halogens are colorful and corrosive nonmetals, and they're found in nature pretty much never by themselves, generally, well, actually exclusively, in combination with some other element. For example, chlorine is often found in combination with sodium in the compound sodium chloride. And the last column, group 8a or 18, these guys are known as the noble gases, sometimes called the inert gases, and they're colorless gases until they've been energized, but they have very low chemical reactivity, hence the name noble or inert. And a good example of noble gases is neon, found in neon signs as shown here. Now the other columns generally don't have names that are commonly used, and so they're usually just referred to by their group number and or letter, but there are a couple names that are somewhat used, not that commonly, and that might be an interesting little bonus thing to look up and see if you come across any other names of chemical groups. And also note that we sometimes use different numbering schemes. If you look across the top, it's 1 through 18, which is now becoming more generally accepted, and the older system of 1A, 2A, and then some 3 and 4Bs as well is gradually going out of favor. All right, a couple other things to note about the periodic table. There are also some important general groupings. The first 2 and last 6 columns of the periodic table are known as the main group elements. The middle chunk of the periodic table, which is 10 columns wide, these guys are called the transition metal elements. And then that last little piece at the bottom, these are known as the inner transition metal elements, and they are known respectively also as the lanthanides and actinides for those 2 bottom rows. One more way we can classify matter is by noting that there are a number of elements that appear shiny, and several are shown on the slide here. These elements conduct heat and electricity very well, and they can be drawn into wires and formed into shapes, and the term for being able to be formed into a shape is known as being malleable, and the term used for ability to be drawn into a wire is ductile. And then these substances also react with oxygen and with water as well as other things, and these of course are known as metals. Now there's a number of elements in the periodic table that have quite opposite properties to metals, and rather imaginatively we call these the nonmetals. And some examples of nonmetals, things that are not conductive of electricity and heat, that are not shiny, are things like sulfur and bromine. Oh, and also not able to be drawn into wires or formed into shapes very well. And then there's a few elements, about 7, that have properties that are intermediate between the metals and the nonmetals, and these guys are known as semimetals, or they're sometimes called metalloids. And the classic example of a semimetal is silicon, the basis of the computer industry. Some periodic tables show the distribution of elements according to metal, metalloid, and nonmetal. And in this periodic table, the metals are yellow. You can see it's the majority of the elements. Nonmetals are blue in the right top corner of the periodic table. And then in between them are the metalloids, shown here in purple.